Today we're going to be deep diving into some advancement made in the Flutter framework itself, which is the Flutter GPU. But before we get into the Flutter GPU, I just want to give you some insight about what the Flutter framework is about. The Flutter UI toolkit, what it is about. It is provided by Google and it in fact allows you to create mobile, web and desktop applications from a single code base. Now we'll look into the Flutter GPU itself. Flutter GPU has been provided to us by the Flutter built-in low-level API, and with that we can do many different things as developers. Earlier, meaning in the past, before the Flutter GPU and Impeller engine was brought forward by the Flutter team, we had something called STIA, the STIA engine. And when we needed to do some custom renderers onto the apps, we had to use native code, for example, C++. We could not really use the dark code directly, but now with the advancement made, we can in fact use dark codes to write whatever custom renderers that you might want. And by that I mean complex ones. So you can have 3D animations that you can make, and it's complex enough. It's not going to be slow, it's not going to be laggy and in any way, form or shape. You don't in fact need to write native codes, native platform codes, nor use the FFI package, FFI plugin that we were using to do these things now. So this is just some advancement and amelioration which has been done by the Flutter team themselves that just allow you to do these custom renderers using dark code and GSL shaders. Now, for those of you who do not know what GSL shaders are, it is just an OpenGL shading language, meaning that it is going to allow you to program some shaders on your graphics card that you're going to display on your screen. But is this Flutter GPU straightforward to use? I would say not really, because the way that it is right now is it is in its early stage. So it's available first of all only on the main channel of Flutter. So if you're going to be using it, you will probably be on the stable channel, if I'm not wrong, and you will have to switch channel using the following commands: Flutter channel main, and that's going to be switching you to the main channel. Now, you might also be thinking, why not use Git? Because as developers, we use Git as well to change branches or channels, as we want to call it. But here it is different. If you use Git and check out on the main branch, you won't be able to do the whole process as it's required, and you're not going to be getting the correct codes, and it's going to be throwing you a whole bunch of errors. Once you've done moving to the main channel, you will have to basically upgrade whatever that we have, because the Flutter team might have introduced new packages. So this is needed to use, otherwise you can get errors about several classes not found or modules not found. We have to also enable Impeller and native assets. Impeller, like I mentioned earlier, is just the latest version of engine that we have, and there has been a lot of improvement made on it just to be able to tackle any optimization and performance issues that we had earlier. So we have to enable this because on the main channel you don't really have Impeller. If you take a look at the root of how its engine is working, it's still on STIA, so we have to move it to Impeller, and that's how you enable it. You're just basically saying, okay, on your Mac OS device, just enable Impeller. You have to also enable native assets. Native assets is going to allow you to integrate some native codes that you can use on your Dart projects. And that's just basically it. Now I will introduce to you the concept of the Flutter architecture before we move forward to looking really into the Flutter GPU usage. Because we really need to understand how it's working behind the hood, why we had to move from Skia to an impeller, probably because there are some issues, right? So we'll look into what these issues are, and also understand the root of the Flutter architecture itself. For you to be able to understand really the Flutter architecture, I'm just going to be giving you here a basic example. Have you ever built a Flutter application before? No? Okay. So when you are building your Flutter application, you have a whole bunch of code to make your UI appear as it's supposed to be appearing. You have your scaffold, which is going to be like a canvas that you're going to be painting on. And then you can add several images to it or text to it. Here, what we are doing is we are only rendering an image on the screen. And that's why we are calling this method of asset, where we will then render this image. Usually, when we look into the Flutter documentation itself and how these are rendered, they usually give us the indication that the build method is the main guy, and that's what is calling the whole tree and building it to make your UI appear beautifully. But that's not really the case, and that's where it gets interesting, because we would think that if you know Flutter, you would think that okay, build method is usually the one responsible, but now there's something else. Well, yes, there's something else, and this something else, the one which is actually really responsible is the UI thread. The UI thread is going to basically set some instructions, and we are then going to be using these instructions to get ready the final output of how we want to display our image. So the UI thread is going to call this build method, it's going to trigger it. And then if you have any logics with this image or anything that you've added with this image, it's also going to make this in form of a set of instructions and then make it in a format that it can send to its graphic card. But how can it do that? And that's where the raster thread comes into place. We use the raster thread works along with the UI thread, and it's going to take this set of instructions and see whatever thing that it has to do with it. So it has to build this image, right? And then it also has to run any logics that it might have. So it's going to do any computation. For example, if you wanted to size your, to give your image a width or a particular height or width, and then even add some opacity to it, this raster thread is in fact going to computate all of this information, and then it's going to send it to your graphic card, and then that's when you really receive your final output, which is displayed on your screen as an actual image. So you might be thinking, where does issues really come when we say, okay, we are displaying an image? Could there be issues? Well, issues could come forward, like we could have pixelated images or even blurry images, and we don't want this to happen. We want a really clear image, and we need to be able to see how we could optimize these images so that we can obtain clearer images. Another thing that we also need to take into account is, and also understand, is Flutter multi-threaded. Well, is it multi-threaded? Do you guys have an idea? There are no good or bad answers. Do you know what multi-threaded is or single-threaded? Okay, single-threaded means that if there are some tasks, say task A, B, C, D, if you're using single thread, it's going to run task A. Only if task A is successful, then it will run task B. Task B is done, then C and D. Now, if you have multi-threaded, its advantage is that you have 4 tasks, right? Say task B is done. It's going to probably show you whatever task B has. Let's say if it was an image or if it was an app logic, it would show you this. And then if task B is done, it will show you that instead of showing you A, then B, and C. If you do not notice, when you load your mobile or your website, what usually happens is that you have certain information which loads first, and then there are several rest which loads later. Now imagine a situation where you were trying to access your website or mobile application, and nothing was loading. You would find it very irritating and just leave this website or mobile application, but you don't want this to happen. That's why we have introduced the concept of multi-thread. So you enter your website or your mobile application, it loads several things, and then if there are any heavy computation which has to be loaded later, it loads it later. So this is a bit what is about single and multi-threaded. So just to answer to this question myself, Flutter is actually single-threaded, but the good thing about Flutter is that even though it is single-threaded, it has introduced a concept of isolates. With isolates, we can basically create isolates to deal with any task that we may want asynchronously. So then you can load your application in a responsive manner, and basically your users won't run away if it's not loading. So that's a bit about UI thread and raster thread and issues and about the Flutter itself. We have here a small demo application that has, of course, a source code are stolen online, just to have more time. And here, this simple application, you might think that, okay, it's just like several buttons or it can have some text, but is that it? Could there be issues if that's a simple application, you think? Okay, no one's replying already, but there are some issues here, even though it's a simple application, and I will tell you how. This simple application running on the CI engine is actually having some performance issues. So when I first run the application and I open DevTools actually throw us an error there that you can't really see, but I'm going to read it to you. It says shader compilation jack detected, and one frame jacked with a total of 391 approximately milliseconds, which has been spent in your shader compilation. And it gives you this error. Now, how's that a problem? Usually, your frame has to load within 1/16th of a second, meaning 16 milliseconds. So whenever it takes more than that amount of second, it's going to cause some jack compilation problem, meaning that it's causing too much time to load on your screen. When we take a look at the charts here, you can see these red bars. These red bars is what indicates the jack issues which you're having. And like I said, if it's beyond 16 ms, it's going to give you these red lines, and that's when you know you have a problem as well. And jankiness really means that your app is just slow and heavy, and you might want to take a look into it, because let's say that you keep on adding things to your application. You might not be thinking that it could cause some issues, since it's just a simple application like such, 2 buttons and text. But the more you add to it and the more you leave these performance issues, the more it adds to how much you will be able to debug later, and you will probably find it more difficult to resolve these issues. Now I will tell you how we can detect these issues and how it can also be resolved, and well, what has been actually been brought forward by the Flutter team for it to have it resolved. One really good thing about Flutter is the DevTools, like I've been saying. and there's only one way to launch your dev tool in a way that you can view its performance is by running it in in profile mode. You have different modes to run your Flutter application. You can run it in release mode or in debug mode, and as well as in profile mode. And profile mode is the only mode that allows for this feature. Now, with this dev tool, once run, we can basically have two main features that we can look into to really optimize our performance and even review what the issues are. These are the Flutter frames and the timeline events. The Flutter frames you've seen here, but I'm going to go into detail now. So here you have a scenario where you are running your application, and it's basically showing you all of these bars, right? What one bar really means is that it just means one frame. So here you have all of these bars. It means that when you're running your application, it's running it per frame, and it's having all these issues on this simple application, which is basically a problem. If you view, you can click on a single bar, and you will be able to see, for instance, details of your UI thread or even of a raster thread. This bar also means that, not sure if I mentioned this, but everything is taking too much time to render on your screen. So it has to be that there are some expensive computations that's happening on this application, and you don't want this to happen. Expensive computation also means that it's going to eat a lot of your storage. So in no time you will be able to see that if you're loading this on your phone, you will have like 16 GB available space. In no time, no space. That's why it's important to fix these. You also have the timeline event, and the timeline event, it just combines information about your UI thread and the raster thread. Here we see that you have the UI on the top, the UI thread on the top, and as when you look at the bars, you will notice that it's very small, and it's taken it has not taken much time to load. But the raster thread, on the other hand, it takes quite a lot of time to even draw on your UI, which means there's a problem. Okay, so you have, I can't really see here, page view raster draw. So this method just says that, okay, I'm trying to draw on your application, but it's taking too much time because there could be some expensive computation. But is it this information that we need to use only to be able to solve our problem? I would say no. This is just a beginning. Now that you know that it's taking too much time, there's some expensive computation happening, and that's why it's not being able to render, you have to take a look at the other methods, which also has quite a lot of time within its method. So among one of these methods there, you have the SK Canva flush. What the SK Canva is really, it's just the Skia Canva. So instead of using the Flutter Canva, it's using the Skia Engines Canva, and it's doing all these drawings that we want to happen and all of this computation. And here it's taking so much time, and that's why we need to, in fact, this is the thing that we need to optimize, in fact. And we can get more information pertaining that, I think, some documentation if you look for it on the internet. But when this is fixed, everything on your application, whether it's the pixels or the gradients, anything that could have appeared on your screen will appear better once you optimize these things. Now, why was the Flutter GPU introduced? Skia was having quite a lot of problems, right? Optimization and performance issues, and we had to do this optimization ourselves. Therefore, Flutter team came forward with a Flutter GPU so that we can reduce these issues, because they don't want you to waste time in really looking into this and doing this by yourself. Of course, you could be having performance issues now and then, but it won't be as much as we've seen here, like all of these problems you won't be having. You will probably be seeing for one frame just one jump, but that's fine and you can optimize it. And actually I don't have my laptop for it, it's not really running, but I had to do a demo. The application that I was going to show you about is a very complex application that the Flutter team has made themselves. It's just an example, but it's quite complex. It's using some shaders and it's using shaders and the Flutter GPU itself. So these shaders, like I'm saying, what it's going to do is, shaders usually it controls everything that you can see on your UI. So every pixel, colors, and everything. You have two types of shaders. You have a vertex shaders, which is going to show how things appear on your screen, and then you have fragment shaders, which is going to determine the colors of these pixels. We have to basically compile all of these shaders in the code itself and make a bundle out of it. This bundle is what you're going to be using to then do whatever that you have to do, make use of it as you may want to. It's just a toolbox basically. It's some tools and some instructions that you're using. And I wanted to actually do a demo since you're quite small number. I think I can use my laptop to show you. I will run the application because I want to show you the complexity of this and how we have really solved these performance issues, and you won't really find any much problem. If it wants to run, of course. Okay, if you could please come here, I'm just going to show you a few things. Okay, I don't know why it's appearing, but usually when you run your application, on the top here, you usually see like debug or profile. I don't know why it's not appearing, maybe the project is still running, but you can also run it as such. So you can run and debug, and you will be able to select your profile node. Here you can select your device. What's happening? Usually here you can select your device. I think it's taking some time to just 1 second. it's running on why, but what this application, okay, I think it's going to do it. But what this application is actually doing is you can have, for instance, 3D cubes, and you can move it around, and you can even change its colors. When you go through the, I don't know what's happening today. When you go through the performance view in your DevTools, each frame, so meaning every time you change these colors or if you rotate the cube itself, it's being done seamlessly and you don't really have any, okay, maybe now I'll be able to run the screen. Yeah, it runs seamlessly and there are no issues really on the Intel engine using the Flutter GPU. Okay, here. So here you have run debug profile. I'm not sure if I can increase this. Doesn't want to increase today. Okay. Run debug and profile. You have this on the top of your main method. Just going to go around with this. You have this run debug and profile modes, right? To be able to access your DevTools, you have to run your project in profile mode, and it's going to be run hopefully. Now it's just debugging. If there are any issues, usually when there are issues, what it does is it just throws this bunch of errors in your consoles, right? So right now it's just saying, okay, I'm running the main.dot on the macOS, meaning the desktop of this machine in profile mode, and it's going to launch it. Hopefully, if it does launch, then I'll be able to show you. Okay. I think it won't launch. Usually, there should not have been any problems. Say you did not have the Intel engine and the native assets like we spoke about before enabled. Then you will not even see these codes that usually you should be seeing these pings saying, okay, it's on this machine with this ID on this architecture. You will not even see these, and it's just going to tell you that probably some modules not available, and you have to configure these settings. So here you have this program, right? And you're able to make sure if I can show you here. Just reduce this size. Okay, so here you have your this is the DevTools which has been opened. You have your Flutter frame on the top, where we had the red bars earlier. This is the timeline, and it's just going to give you a bunch of information. There's too much happening. You might want to just select one frame and see what's happening for that frame, right? But right now, it's working pretty well because we don't really see much of jumps. You could probably have some, but it's not that much. And these are things that you can optimize, right? So here, it's running in the background, and I can change it. As you can see, no red lines behind. I have this 3D cube, I can change it. No red line appearing on the Flutter frames. So these are just some ameliorations which has been done by the Flutter team, and you can do a whole bunch of things. This is just a very small application, but you can build games with it, you can build very complex animations with it, you can have 3D animations as well, and it's going to run just fine. And that's what your basically the Flutter GPU is about. And that's it for me. I am Zahra. I did not introduce myself earlier. So I am Zahra, a software engineer and also Google Women Tech Makers Ambassador. I do mentoring for Flutter, also on other technologies like React. Yeah. And I also write blog posts. You can find me on LinkedIn or on Twitter and reach out to me if you have any questions or freelance work. Yeah, that's 40 bucks. If you have any question, you can let me know. Do you have any question? Yeah.
Okay, thank you. So I have a question about isolates.
Yeah, I can't really hear my so I'm just. Yeah,
I have a question about isolates.
Isolates?
Yeah, can you explain more like how they differ from the traits? Can you go more deep in how they differ from other multi-threading systems? Like how they work?
Well, the concept of isolate, I can't really go deep in that because we have to do say a whole different session. Maybe that's one at a time, but I'm just going to tell you briefly. Isolate happens to be there because, like I said, single is single-threaded. Things are not going to run asynchronously, it's going to run synchronously. And we don't want this to happen, right? That's why you have this concept of isolates. You create isolates if you want your tasks to run in parallel. That's just about it. That's just the overview that I can give you. I can't really go in depth because that would require a whole different session. Yeah. Any other question? No? All right then. I think that's it for me. Yeah.